Hello friends, in these sessions I am going to discuss about this electric field, which is a continuation part of first chapters of second PU, that is electric charge and field. We already discussed about electric charge, and my friend Harish Shastri sir is introduced about these electric charges in a previous sessions, and also he was able to explain about this all the properties of electric charge. And in this electric charge, in these sessions I will cover what is the electric field. Friends, we have to know about this electric field, which is a very important part of this chapter, and what is the definition for electric field, SI units and its dimensions, and expression for electric field due to a point charge, electric field due to a multiple charge and its physical significance, as well as some two numerical problems which is oftenly asking from these particular chapters. ಈಗ ಈ ಸೆಕ್ಷನ್ನಲ್ಲಿ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಂದರೆ ಏನು ಮತ್ತು ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿನ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಏನು ಡ್ಯೂ ಟು ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್, ಹೌ ಟು ಫೈಂಡ್ ಔಟ್ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಈಗ ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಇದ್ದರೆ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು ಯಾವ ರೀತಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು, ಹಾಗೂ ಇಟ್ಸ್ SI ಯೂನಿಟ್, ಅದರ SI ಯೂನಿಟ್ಗಳ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್, what is the electric field? Why this concept is introduced in physics? See, if you have a charge, let us say Q is a charge, and I will bring another charge nearby it, it will experience a force that already you know in a Coulomb's law. And from this Coulomb's law, it is explained that if I to have a point charges, it will experience a force at a certain distance. And you know that if it is like charges, they are repels, and unlike charges, it is attracts. Now, why this particular force will experience is one of the fundamental force in physics, electrostatic force will experience. How the force will experience? And scientists are thought based on this, if I have a point charge nearby it at a certain area, ಅದರ ಸುತ್ತ ಇನ್ನೊಂದು ಚಾರ್ಜನ್ನು ನಾವು ತಂದರೆ it will experience a force. ಯಾಕೆ ಆ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುತ್ತೆ? ಅದೇ ಆ ಚಾರ್ಜನ್ನು ದೂರ ತಗೊಂಡು ಹೋದರೆ ಅಟ್ ಎ ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಟ್ ನಾಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಎನಿ ಫೋರ್ಸ್, ಆ್ಯಂಡ್ ಅಟ್ ಎ ಸರ್ಟನ್ ಏರಿಯಾ ಇಟ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಎ ಫೋರ್ಸ್. ಇನ್ ಆರ್ಡರ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್, ದ ಸೈಂಟಿಸ್ಟ್ ಅನ್ ಅರ್ಲಿ ಸೈಂಟಿಸ್ಟ್ ದೇ ಇಂಟ್ರೊಡ್ಯೂಸ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಆ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎನ್ನುವ ಕಾನ್ಸೆಪ್ಟ್ ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ನ ಹತ್ತಿರ ಇನ್ನೊಂದು ಚಾರ್ಜನ್ನು ತಂದಾಗ ಅದು ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುತ್ತೆ. ಆ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಅಟ್ ಎ ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲೇ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗಬೇಕಾದ್ರೆ ಸಮಥಿಂಗ್ ಶುಡ್ ಬಿ ಪ್ರೆಸೆಂಟ್ ಅರೌಂಡ್ ದಿಸ್ ಇಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್. ವಾಟ್ ಎವರ್ ಸಮಥಿಂಗ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ is taken as a electric field. That is nothing but electric field. And what type of force it will experience? Suppose a certain point, suppose I will keep a positive charge, and this charge which produces a field is called source charge ಅಂತ ಹೇಳ್ತೇವೆ. ಆ source charge ಅಂತಾರೆ, it is a charge, certain charge, it is able to produce a field around it. ಅದೇ ರೀತಿ ಇನ್ನೊಂದು ಚಾರ್ಜನ್ನು ಇಲ್ಲಿ ನಾವು ಬರೆದಿದ್ದೇವೆ, ಅದನ್ನು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಇಟ್ಸ್ ಅ ಸ್ಮಾಲ್ ಚಾರ್ಜ್, ಇಟ್ಸ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇಸ್ ವೆರಿ ಸ್ಮಾಲ್ ಆ್ಯಂಡ್ ನೆಗ್ಲಿಜಿಬಲ್, ಬಟ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಏಬಲ್ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಇಟ್ಸ್ ಓನ್ ಫೀಲ್ಡ್. ಅಂಥ ಒಂದು ಚಾರ್ಜಸನ್ನು ತಗೊಂಡು ಅದರ ಎಟ್ ಎ ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್ ಸಪೋಸ್ ಎ ಪ್ಲೇಸ್, and around this distance, around this particular area, it will experience a force. Suppose this test charge is always taken as positive charge, and it will experience a repulsive force. Suppose it is brought near a positive charge, and it will experience a attractive force. Suppose it is negative charge, if Q is negative charge, it will experience attractive force, it is attracted towards it, and Q is positive charge, it is experience a repulsive force. And this charge, source charge, whatever it is, it will produce certain field around it. And about this electric field, we are defining, okay, the definition says that what is electric field. Therefore, electric field is a, due to any charge Q at a point P, is defined like that, is a force on unit positive charge it will experience if it is placed at that point. That is definitions they are given for electric field. Electric field ಅಂದರೆ ಏನು ಅಂತ ಈಗ ನೀವು ತಿಳ್ಕೊಂಡಿದ್ದೀರಿ electric field ಅಂತಾರೆ it is a space around a point charge such a way that ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಅನ್ನು ಅದರ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಏರಿಯಾಕ್ಕೆ ತಂದಾಗ ಇದು ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆದರೆ ದೆನ್ ವಿ ಸೇ ದ್ಯಾಟ್ ದ ಬಿ ಫೀಲ್ಡ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಅರೌಂಡ್ ದಿ ಚಾರ್ಜ್. ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಏರಿಯಾ ವಾಟ್ ಎವರ್ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಅದನ್ನು ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಓಕೆ, ಆ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು ಡೆಫಿನೇಷನ್ ಏನು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋ. ಯಾಕೆಂದರೆ ಎಕ್ಸಾಮಿನೇಷನ್ಸಲ್ಲಿ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡನ್ನು ಡಿಫೈನ್ ಮಾಡಲಿಕ್ಕೆ ಹೇಳ್ತಾರೆ. ವಾಟ್ ಈಸ್ ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ definitions? The electric field due to a charge q at a point p is defined like that. For example, consider a point charge q at a certain distance. Suppose I want to find out what is the electric field due to charge. For that, I will define like that. Suppose I will place another small charge plus q. We say that test charge. Then what is the force experience on this test charge, and that is defined this particular electric field at this point. And definition says that electric field due to a charge q at a point p which is at a certain distance r from this source charge is defined like this. It is a force that unit positive charge would experience if it is placed at that point. What is the definitions? It is a defined like that. The force that unit positive charge would experience if it is placed at that point. And based on this says that mathematically we can give the relations like that. Electric field E is equal to the limit of F by Q, where F is a Coulomb force experienced by that particular charge Q, and such a way that Q is tending to 0. That means Q means it is a negligibly small in magnitude, and such a way that if you place at a small magnitude charge, what is the force experienced by that particular test charge per coulombs, and that is giving what is the electric field at that particular point. I can say this relation we can simplify like that. Electric field is equal to force on this electric test charge divided by magnitude of test charge, so that Q is E is equal to F by Q. Let us see what is the SI unit of this electric field. Therefore, electric field SI unit is Newton per Coulomb. Why? Because the relation for this electric field I already given is a F by Q. F is force which is measured by Newton, Q is Coulomb charge of this test charge, that is coulombs based on this Newton per Coulomb. We have another unit also SI unit we use, that is volt per meter or Newton per Coulomb. Let us see what is the dimensions. Dimension of electric field. Dimension of electric field again is given by based on this dimension of force divided by dimension of charge. And you that dimension of force we already studied in first year physics, that is a m1 L1 T minus 2, and dimension of charge. It is not a fundamental quantity, it is a quantity derived based on this current. Current I is equal to Q by T, and based on this Q I can say it is a current into time, because current and time are fundamental quantities. We will give a dimension for current and time, and based on this getting relations is like this. It is current is ampere and time is T, and it can simplify like this. It is like giving M1 L1 T minus 3 a to the power minus 1. This is the dimension of electric field, which is commonly asking in some of the CET questions also. And let us give the expression for electric field due to a point charge. And expression for electric field is once again is obtained based on this relation between electric field and a force experienced by a unit test charge placed at that point. Let us see this test charge Q is at a certain point O, at a certain distance. I want to measure what is the electric field. Then what is the expression, mathematical relation or expression for electric field? It is given like this. It is a force on unit positive charge placed at that point, and like that at a distance r from this charge Q, capital Q, what is the force, what is the field at this point is given by force on this charge divided by magnitude of charge. And you know that on the basis of Coulomb's law, in a previous section you studied, force between these two charges, that is a 1 by 4 pi epsilon naught into product of this magnitude of charge divided by square of the distance, based on this 1 by 4 pi epsilon naught q into q divided by r square. Now here into 1 by q, what is denominator q is there, I will written here, and this q and q is cancelled, and its direction is given by its, since both are positive charge, it will experience a repulsive force. As a result, it is directed along OP or along R unit vectors I written here, and it is simplified and written the expression for electric field due to a point charge, that is 1 by 4 pi epsilon naught q divided by r square into r cap. And let us see directions, how we can obtain a directions. I written already r cap, but it is like this. What is the direction with which this test charge will experience a force, that is giving direction of electric field at this particular point. Suppose in this picture you see here, suppose I will place another charge here, it will experience a force like this. It is the experience force that is giving the direction of electric field at this particular point, or I will keep this test charge here, then it will experience force like this. This is giving the direction of electric field at this particular point, such a way that what is the direction with which that test unit positive charge will tend to move, that is giving a direction of this electric field. And this is very important. Usually this mention the expression for electric field is asking, and explain its terms and what are the factor depends. And let us see here in these equations, it is independent of magnitude of test charge, it is depend upon only magnitude of source charge, as well as it is inversely proportional to square of the distance, or E is inversely proportional to square of the distance. What is the meaning of this, students? Now it is indicates that it is inversely proportional to square of the distance, means as the distance is moved away from this charge, the strength of magnetic electric field will decreases, or the field will decrease as we move away from this charge, and field will be more and more stronger as you move closer to this particular point charge. And that is one important thing, so you have to remember electric field is independent of magnitude of charge, that is test charge, and is depend upon magnitude of source charge as well as distance between them, and these square factors, that is a 1 by 4 pi epsilon naught. Suppose here we are assuming that it is placed in a vacuum, suppose some medium is present, then it also depend upon medium around it, and here it is written as 1 by 4 pi epsilon naught. Epsilon naught is permittivity of the medium, air as vacuums. Suppose some medium is present, then it depends. And then we will discuss about this electric field due to positive charge as well as negative charge, how it is there, and I will show this with the models, and this is appearing the imaginations we can get from this positive charge, how it will giving the directions. Suppose we place a charge nearby this particular positive charge, it will experience a force like this, and such a way that around this particular point charge it will experience force in this way, it is radially outwards, or this is a imaginary way we can appears around this particular positive charge, and electric field around a positive charge is always radially outwards, that is the direction of electric field due to positive charge. Suppose instead of positive charge, suppose have a negative charge, and if it is negative charge, if you place another test charge is always we are using a positive charge, then it is attracted towards it, at any point it is attracted towards it, such a way that the direction of electric field around a negative charge, it is always radially inwards, and such a way that the number of electric field lines, it is directed towards it or radially inwards. That is about electric field around a positive charge as well as negative charge. Okay, we will continue this electric field. Now we studied about electric field due to a point charge. Suppose I have a single charge from a source charge q, what is the electric field we discussed, Now, I suppose I have a number of charges, or you can say a system of multiple charges present on it, and how to find out electric field at any point nearby it. And electric field due to multiple charges, let us we have a system of charges q1, q2, q3, q4 etc. at a various positions at a distance from origin at r1, r2, r3, r4 etc. What is a electric field at a point O? Okay. How we can find out electric field? For that we are using Coulomb's law as well as principle of superpositions. Using principle of superposition and Coulomb's law, we will find out what is the electric field at this particular point O. Now, how we can use this particular, because since electric field is a vector quantity, what is the electric field? It is a vector quantity, and we have to consider both magnitude as well as directions. Of course, Coulomb's law, due to this point charge, we will get expressions by E is equal to 1 by 4 pi epsilon naught q divided by r square into r unit vector, that is r unit vector is giving direction of electric field. This is a electric field due to a single charge. Now, we have a multiple charge, then how to find out electric field due to a multiple charge? Let us take q1 is a point charge which is at the distance r1 from O. Then due to this electric field, suppose I will place a unit positive charge at this particular point, assuming that this is also positive charge, then it will experience a repulsive force. On the basis we will get a electric field due to this charge q1, that is E1. But that electric field due to this charge q1 I will take as E1 r1 vectors. And I have another charge q2 which is at a distance r2. Then if it is positive charge, q2 is positive charge, then it also experiences a repulsive force test charge due to q2, and it is giving a direction is E2 in these directions. And due to this charge q2, it will produce a electric field at this point O, that is E2. And suppose this q3 is negative charge, q3 is negative charge, then it will experience an attractive force such with the direction of electric field due to this q3 is E3, and so on. Like that, it is giving a number of electric fields at this point. Now, I have to find out what is the net or resultant electric field. Let us take a resultant electric field at this particular point is a vector sum of this electric field which is produced due to this number of charges. Let us take E1 R1 vector is a electric field due to charge Q1, and E2 vector is a electric field due to charge Q2, and E3 is electric field due to charge Q3, and so on. Then we have to find out what is a vector sum of all the electric field, and that is giving what is a net electric field at this particular point O. And how to find out this vector summation of this electric field? We will use law of parallelograms for vector additions already studied. For example, I have two vectors which is like two adjacent sides of parallelograms, then the diagonal of that parallelogram is giving a resultant of these two vectors. Then I have another vectors E3, and again use this law of parallelograms, and it is giving a resultant of this E1 vector and E2 vectors as well as V3 vector, in such a way that it is giving resultant of these three vectors. So that suppose as a number of electric field vectors is getting, you add all the electric field vector vectorially, which is giving electric field at this particular point, and such a way that we will work out some numerical problems, then you can understand and how to find out electric field due to multiple charges, and this is useful only for a numerical problems. Now, what is the physical significance of electric field? And this electric field will explain about this particular strength of this electric field at this particular point we can measure. And for example, I have a charge Q at a point P. What is a force experienced by this particular charge which is placed at this particular point till giving electric field, and it is same at everywhere at a particular distance. At a particular distance it is same at every point and it is producing a sphere. Suppose it will produce a sphere at all this particular distance, since charge q is constant, it will produce a uniform electric field. But as the distance increases, electric field strength or electric field intensity decreases. As distance decreases, electric field strength is increases, and is useful in many cases. We have to find out electric field at this particular point.